Thank you everybody for showing up. Today, what we're wanting to do is kind of show you some tips and some tricks with using the ClearEdge 3D Verity software. So with that being said, today I do have Trevor with ClearEdge 3D. He's their senior software specialist here helping us with this demo / training. And myself, my name is Andy Huntley. I'm the National Sales Manager for Scanning Technology. So with that being said, Trevor, you on here?
Yep, there we go. Can everyone hear me okay?
Yep, I can hear you.
Perfect. For anyone who's not familiar, just to kind of give a little bit of background on what Verity is. Verity is going to be ClearEdge 3D's premier tool on construction verification. So what it is going to be a companion tool for Navisworks. And anyone who's not familiar with Navisworks, Navisworks is Autodesk's own premier tool for coordination. So pretty much it's a way that anyone can take model geometry, point cloud data, and basically view it in one central location. And traditionally, what Navisworks is used for is clash detection. So that way the MEP guys can clash against the structural guys and basically do solid to solid clashing. The value added from Verity is that Verity allows you to bring in the model geometry and compare it to the point cloud representing the as-built conditions. So again, that's what Verity is. So now let me go through and share the screen and let's get started. So this is going to be our starting point for our Verity workflow is we have a couple things. Number one, inside of Navisworks, we have our model geometry. That model geometry can be anything. So not only like structural steel, you got MEP, pretty much as long as it actually exists and you can bring that geometry in Navisworks, then it's going to be fair game for an analysis. The second thing is going to be the point cloud itself. So with the point cloud, one of the big tips that I give is having control. And especially using the GTL, that's a great workflow because you can get a point cloud on control. The reason I want to stress that is because how well that point cloud is aligned to the coordinate system that the model is in, that's directly going to affect the accuracy of the Verity result. And again, by using that GTL robotic total station combo, you can probably get one of the best alignments between the point cloud and the coordinate system. So that's kind of going to be the starting point for our Verity workflow is again having the model geometry and the point cloud. So with that, we're going to actually begin our Verity workflow and bring in some geometry as well as some items and kind of talk about our QA/QC. So first of all, I'll go ahead and bring in some model geometry. So another key tip is Navisworks itself, selection sets. With the selection sets, this is actually a really great way that we can pick out items that we want. And once we have the items picked out, we can actually save that. The reason that's so important is because if we're trying to do change detection or progress tracking over time, we can always have the same selection of elements selected inside of Navisworks. So that way it makes it super easy for when we have additional scan data coming in, we simply grab what we've done previously using that saved pick set, and that way we can, compare changes as new point cloud data comes in as the project progresses. So another key pro tip that I always like to tell people is especially for larger projects, I like to do a little bit of kind of QA/QC of the item set that I already that I'll bring in. So for example, a lot of brand new Verity users, what they'll do is they'll say, for example, plop in like the whole MEP model. So not only are they getting the major pipes, but they're also getting the conduits, kind of also like the smaller objects, maybe stuff that we're not really interested in inside of Verity. A good one for the steel is if people bring in the steel model, not only are they going to get the major I-beams, but they'll also probably get the plates, kind of the bolts. Again, really kind of that little stuff that, not really interested in, I guess you could say. So one of the biggest tips that I like to give new Verity users is to do a little bit of cleanup on the item selection as you bring it in. And so the way I like to do that is once I have my items loaded into Verity, I usually like to do a sort by the geometry surface area, and that allows me to clean out, again, a lot of those smaller objects that might not have enough point cloud data for, again, to get an accurate result anyways. And then that would be like, for example, I keep coming back to it, like the bolts. If those are modeled, especially for a very high level of detail model, I'll clean those out because, again, that's just going to kind of, that's just extra elements that'll slow down our analysis, especially if we're interested in kind kind of the major steel structural sections. The next thing I'll kind of talk about once we have our items loaded in is actually going to be the scan data. So with the scan data, Verity does not need really dense scans. Verity actually only needs roughly about 1,000 or so points evenly distributed along an element to get a good, accurate result. So again, prioritizing coverage over density. If you do have incredibly dense scan data, two main ways I would recommend is A, doing a decimation inside of Recap, or the big pro tip that I like to give people, especially if they don't really want to decimate their data, is instead of grabbing like every scan position, be a little bit selective and maybe grab like every third or every fourth scan position. Again, kind of doing a pseudo decimation just by picking out the scans, ensuring a good level of coverage, but not picking like, 2 scans that have like 80% overlap. So that's kind of another little pro tip there. And I can do all that by coming over here in the selection tree, and I'll just grab I'm just going to grab my first 3 scans like that. Once I have those grabbed, I'll go ahead and go add to Verity search tree right here, and this will import my scan data down here on the left, and now we have our items. Once we have the scans and items loaded in, this is where we'll go ahead and talk a little bit about the analysis and how we can perform that. So we'll come over here to our Analyze button right there, click, and then we have a couple options. The most important one is going to be this tolerance value up here at the top. This tolerance value right here controls the distance value that Verity will use in flagging elements, whether or not they're in tolerance or out of tolerance. This is where you can initially set it, but later on, I'll show how we can actually adjust it. Say if we want to have, we realize, hey, someone asks like, can we actually drop that or can we increase it? We can actually control that later on. One other little thing I'll point out is also the advanced section right here. The advanced section allows us to actually tune Verity's algorithms for specific data sets. So for example, you can input values for expected scanner noise as well as expected surface deformation for say doing if you're working more like on a historical structure. And the big one is going to be the minimum number of points. So this allows you to control the data threshold that Verity needs in flagging an element saying, hey, this is found in the point cloud. So again, kind of gives you a lot of control, or if you want, you can just kind of keep the simple options right there. So with all my options set, I'll go ahead and click OK, and we'll go ahead and let the analysis run. So during this analysis, Verity is going to be doing a couple things. Number one, Verity is going to make a judgment call and say, is this element found within the point cloud? If it's not found, it'll flag it and say, hey, this element is missing. If it is found, what Verity will then do is say, is this element within tolerance of where it should belong? If it's in tolerance, good, great, well done. It has been installed correctly in the field. If it's out of tolerance, what Verity will do is it'll create a copy of that geometry. And it'll take that copy of the geometry and refit it back to the point cloud to get you your true as-built condition of what should be there. In addition to that operation, Verity will also do 2 things, and that's going to be calculating the metrics. So it'll give you the full translation metrics of how the element is moved, as well as the point cloud data itself. It'll take that point cloud data and actually classify it and generate several heat maps. And so those heat maps are an especially powerful tool for kind of understanding some of the more subtle as-built conditions, like for example, warping on steel, any bowing on like, for example, like an elevator shaft. That's all becoming very apparent with the heat maps. At the end of the Verity analysis, this is what opens up. This is the summary report. So the summary report right here is a nice little pie chart overview, just kind of letting me know the overall results. For example, we have about 2 elements that are not found out of our total, and looks like a good chunk of these are out of tolerance. This summary report right here is a good record, especially if I want to do progress tracking using Verity. I can save out multiple summary reports, especially as the construction progresses and additional scan data comes in. And again, this provides me basically a stamp of saying, hey, what's been built for completion at this time, say, for example, for billing purposes. So I just like to point out down here, this is like the total errors down here in the bottom left. This kind of gives me a heads up about what I'm about to dive into. So for example, we can see the smallest and largest deviations, as well as we can see the average right here. Now let's go ahead and circle back to Verity and talk a little bit about kind of what we have after our Verity result. So number one, if we take a look in the 3D view, we have the point cloud itself in white. And then if I turn off the points, we have two pieces of geometry. The purple or magenta, that represents the design element, or the element as it currently sits inside of Navisworks in our design model. The cyan or teal, that represents the copy of the geometry that Verity has actually created and refit back to the point cloud to get us our true as-built condition. At the bottom, if you follow your eyes to my cursor, we can see the metrics itself. So for example, like right here, starting on the left, we have 70% scan coverage. We can see this element is installed, and at this 1/2 inch tolerance, it's currently out of tolerance. The next 4 columns will actually come back and talk about those a little bit later. But now I want to point out the translation values. So for the translations, I can see this is like 7 inches out of tolerance, and then it breaks that number down into the vertical and horizontal vectors, as well as the project X and Y. So again, full translation metrics in addition to the visual, kind of letting me know how this element basically is differing from the field from what was designed. Also, another thing I want to point out real quick, the analysis themselves are always saved. So that way we can actually go back in time. You can see, for example, these are all the analyses I have for this project. So that way, again, as I'm scanning regularly on site, I can reload a previous analysis and actually do kind of, hey, what's changed? Have things been fixed? I have it all as a record using Verity on the construction site. So very powerful kind of tool right there. Going back to kind of the now what, now I want to talk about some of the QA/QC workflows and how we'll actually dive in as a user and kind of check these elements out. One of the most important tools I have inside of Verity is going to be the split tool. It's a split view. So the split view will split out the view into these four primary views. So that way it can quickly, again, see how the element is fitting to the point cloud. These views are actually pretty unique in that I have the option to come in over as a user, and I can actually left click and drag that copy of the geometry. So again, if I need to take back control and do some manual updates, I can do that. If I kind of want to adjust the fit, I can get it close. And then once I have it close, there is a refit tool inside of Verity. So this refit tool is where Verity will rerun the algorithm and take that element and just fit it back to the point cloud. So that way, in case something happens where we have to go through, we can get it close and then again, leverage that computer algorithm to take back control and kind of do the finalized fit for us. So that's kind of another unique workflow inside of Verity right there. In addition to that, the next thing I want to talk about is going to be the point cloud itself and how we can use that. So with that, this is where we'll go ahead and discuss the heat maps. So inside of Verity, there's going to be 3 different heat maps. The first heat map I want to talk about is going to be the as-built heat map right here. You'll notice green is good, or have a good fit of my point cloud to the data, or my model geometry to the data. Yellow and red, those are going to be points that are kind of bulging out from my element, and blue would be points that are kind of sinking inside my element, or points that are too close. That heat map is also completely adjustable. So what I can do is actually go through and set my own gradient ranges, as well as I can control the distance value of how much change each color represents. Again, something the user has full control over. So that is the as-built heat map. Another unique heat map I want to show is going to be the as-designed uncorrected. So the as-designed uncorrected heat map right here, if I turn off a couple things just so we can see this a little bit better, is going to be a clash. So this is basically a clash detection heat map right here, showing how the point cloud is intersecting with the design model. So for example, any points that are inside are blue. If it's touching, it's green. If it's on the outside, it's red. The reason I want to point this one out is because this heat map is really good for doing, say, floor slabs. I can take that point cloud data representing my as-built, compare it to the design condition of the floor slab, and that's another way I can basically get deviations on that floor slab and see my high and low spots. So that is the as-designed uncorrected heat map. The last and probably the most unique heat map inside of Verity is going to be the as-designed heat map. The reason I want to show the as-designed heat map is because if you take a look in that top left view, you'll notice how all the green went away. And the reason for that is the as-designed heat map is intelligent in that it knows where the point cloud data should belong. So even though it is touching our element, it knows it's basically still in the wrong spot. So it's coloring it as out of tolerance because it's farther away than what it should be. So those 3 heat maps are probably, again, going to be some of the most powerful tools inside of Verity, where I can go through and really see kind of more of those subtle as-built conditions. As I mentioned before, I can use the as designed uncorrected for like floor slabs, but like the as-built heat map, I can use that for fabrication analysis. I can basically run my parts through and take a look at, say, for example, hey, how is the beam like warping or twisting? And I can see that. The heat maps are a very powerful visual tool, but now I want to talk about a couple of the more, I guess you could say, the more numerical tools inside of Verity. And those are located right here. So change this around. That's going to be these 2 down here. So the first one I want to show is going to be the measure scan point distance mode. What this allows me to do is I can actually click on a spot on my as-built copy of the geometry, and it gives me the distance from that spot to the closest point cloud data. The reason this tool is so important is coming back to, like, for example, our floor slab scenario. I can use the heat maps to visually see my highs and lows, and then it can come with this tool and actually take numerical samplings to figure out how far is it actually deviating in that spot. In addition to the measure scan point distance mode tool, I also have this one right here, and this is the distance between the as-built and as-designed geometry. So what this allows me to do is I can click on a spot. We're going to go like up here. Let me turn this off so we can see this a little bit better. Go like right here. There we go. Just so you can see this a little bit. So this gives me the distance from that spot in the as-built geometry to the identical location on design. So it gives me the total distance, as well as it breaks it down into the X, Y, and Z vector components. So those are kind of the main tools that I like to leverage inside of Verity, where I can go through and basically using the heat maps, kind of understand, and then come back with these tools to actually get, okay, how far, and kind of get the numerics behind that. Once I do that, this is where I'll come over here and have 2 nice little fields, my action required and notes field. And these are basically text fields that I can leverage to type in any information, basically add any, basically anything I want to be exported in my reports. So for example, if I need to update this model, I can make something like, I don't know, update model. Then I can make a note, like turn back on our heat map. We can see there's a sag in the center, so that might be something I want to note for my report. So like right about there. Once I do that, I can put my initials right here in the active reviewer pane. Go ahead and click accept current status. That updates the status for reviewed. And I can go ahead and move on to my next element. So I'll kind of go through, check things out. So I'll go like this one right here. That's looking good. So a couple kind of little situations I want to talk about is like right, like this one right here. If we do come up with an area like this where we can see as a user, there should be an element here, but this might have not had enough point cloud data on it, so it failed and didn't trip Verity's threshold for being found. So in that case, we can actually come over to our drop-down menu, manually change this to installed, and then Verity will go ahead and show us, hey, this is the element, the as-built element that it wanted to create. So again, super simple to go through and kind of correct, even if we have the odd false positive. So again, I'll kind of go through, check my elements, and at that point, let's go ahead and talk about taking this information out of Verity and kind of pushing it and working with it inside of Navisworks. So quick, I guess you could say, note. Biggest pro tip I can say is investing in dual monitors. If you have dual monitors, it's absolutely amazing to work with both softwares kind of side by side. So the reason I point that out is because right here, we have these kind of 3 little buttons, or 3 checkboxes, and kind of this section up here. So the first one I want to show is where I can click on an item inside of Navisworks. And then if I click on this button, which is the import selection, it'll take me to the identical item inside of Verity. Furthermore, there's this little checkbox called Match Viewframe. Match Viewframe will sync up the camera between both software applications. So any manipulations I do in one will be mirrored in the other and vice versa. As you'll notice, if I kind of navigate around here, you see this project is it's got a lot going on, and it can be a little bit difficult for me to find the, the pipe. So in that case, I can turn on my inspection mode. The inspection mode will adjust the transparency inside of Navisworks, so that way only the element I'm looking at is going to be non-transparent, allowing me to kind of quickly see like so. Furthermore, if I actually need to kind of see the element even further, I can turn on my section box. So the section box command will pretty much do what the name says. This will throw on a section box inside of Navisworks. So that way, again, I can completely isolate the element and see, hey, what's going on over here. So this whole workflow and everything I'm showing right now, this is where I can use Verity to see the element completely by itself, and then I can use Navisworks to see the context or the element in the context of the whole project. That's kind of the main power between the two, is a very kind of almost dual understanding to get the furthest kind of information out of my as built versus as designed. So let me go ahead and turn this off, and let's actually go through right here, and there we go. So another kind of cool thing I want to show is pushing the actual properties and how we can kind of bring this information into Navisworks. So with that, if I turn on my properties right here, you'll notice how I have a Verity tab. So this Verity tab, what that allows me to do is I can push my metrics. So I can do this one at a time. I can do it for groupings of elements, or by using this lock button. This lock button will actually make the link live so that any kind of changes I do, if I adjust anything inside of Verity, will be automatically pushed back to Navisworks. Part of that, it also will color code the items inside of Navisworks, so that way I can quickly get a 3D deliverable showing, very simple to understand, what's in tolerance, what's out of tolerance. And that we've gotten a lot of great feedback on. That's probably one of the favorite deliverables our clients like using. They can just send over the NWD that's color coded, for example, with all the steel. Super easy for the owners to understand basically, what's in tolerance versus what's out. So another cool thing, actually, just to show this real quick, is if you watch this pipe over here on the left, at the click of a button, I can actually shift this over to the as-built location. So this was one element. If I hold down the lock button, I can do it for all the elements in the analysis. You'll notice how this is about 17 items, but if you can think, if we've analyzed, say, the whole structural project, which is 300 to 400 I-beams, this is how it can convert from as designed to as built inside of Navisworks to get an accurate model for coordination. The other thing I'll point out is by holding that lock button, any changes I do will be mirrored. So like I said, I can manipulate the as-built copy inside of Verity. You'll notice if I do any changes, that will automatically be pushed over inside of Navisworks. Again, kind of syncing up the two softwares with any changes that are done. The next thing I'll kind of go ahead and talk about and kind of want to show for this is actually some of the reporting. So for the reporting, a couple different options. Number one, HTML reports. With the HTML reports, we're going to focus on this table and items one right here. HTML offers a nice light solution where you can basically pop out these reports. They usually only tend to be about a megabyte or two. That way, anyone with an internet browser can actually go ahead and view these reports. So a common tactic is we can export these reports, email them to someone in the field, and then they can use their iPhone or mobile device, view these reports, and then double check our work for field verification. So quick little example of the HTML report right here. We have the overall item table, as well as we click on our individual item links over here on the left. It'll give us the same split views that we had inside of Verity with our heat map turned on, for example. Any action required notes, that'll be present, as well as we have the element location in the project X, Y, and Z coordinates. This is actually an especially useful piece of information because we can export out a CSV file of the item table, and by using that XYZ coordinate in the project coordinates, we can actually take that information and load it back into, say, for example, the GTL, and then using that robotic total station, we can have it walk us on site to, hey, where is this element in the field? So that's kind of the example of the HTML report right here. The other big one, and this is probably the one that I use most, as well as most clients, is this one right here called Smart Points. Smart Points is a point cloud export. The way it works is we can grab and select any items we want inside of Verity. For example, we could grab everything that's out of tolerance by 3 inches and greater, and then we can export out just the point cloud data for those elements. Either we can do the main point cloud, or we can export out the heat maps. So the way that would look like is if I load this, I've got one already exported. So we can do something like this. And we'll just hide everything. So there's an example of the heat map just for this kind of grouping of elements that I've been working with today. So a very powerful tool. The reason for that one is because this allows us to take the information out. Again, especially this information right here that shows kind of those subtle as-built conditions. Pop it out as a point cloud. That point cloud will be in the same coordinate system as the model geometry. I can bring that back into Navisworks, or I can take it a step further and bring it back into, say, for example, Revit, overlay this heat map on my Revit model or even my CAD geometry, and then show, hey, this is what needs to be updated or fixed, or this is what we can use to kind of fix and tweak our, I guess you'd say like the master model in Revit. And lastly, I want to talk a little bit about the Publish tab right here. So the Publish tab has integrations with BIM 360 Field, BIMTrack, and Procore. So if you're using any of those project management softwares, you have the ability to basically insert Verity in your workflow, and that way Verity can take any results, push them as issues, and that way everything can be tracked and controlled kind of one central environment. And that's kind of my general kind of look at Verity. So now I actually want to switch gears a little bit and show a little bit larger of a project and talk about a little bit different of a workflow. And that's using this one right here. So this is about 300 structural steel members. So with Verity, as I mentioned, we can kind of work almost like in a side-by-side manner. I can push my properties in those color codes over. Quickly, I can see my highlighted model. Okay, what's going on here? And once I have that, I can use this as a way, for example, like these red ones are out of tolerance. I can almost do like more of a visual check. So I can say like, okay, what's going on there? Or let's check like this one right here. And there, that I-beam is about, shoot, that's even out of the search radius. So this is a good one to show like, hey, this really did not get built right. In that case, what we can do is, as I mentioned before, manually change the install, move this over to the correct spot of where it should be, rerun that refit tool, and this is where we can get the actual result. Give it a sec. There we go, and we can see this beam is, and just switch over to, this is almost like 8 inches out of tolerance in that spot. So that's kind of a quick little pro tip of how I can work more of in a visual way by pushing over those properties, kind of more visually doing a QA QC by focusing on my color codes, importing it over, as well as doing any changes by, again, changing the install status manually, dragging it over, then I can leverage the software to get the updated true result. All right. Any questions about anything that I've talked about or showed today with Verity?
Hey, Trevor. Yeah, this is Mike Phillips. Somebody asked me, does it matter what scanner we use with Verity?
Short answer is no. As long as it is, basically, as long as it is a non-unified recap project, you can use that data with Verity. That being said, I would highly recommend the GTL. The reason for that is since the GTL is built upon a robotic total station, you can get probably the most accurate point clouds on control. And having a proper alignment of that point cloud in the known coordinate system, that's basically critical for getting the most accurate result using Verity. Did that answer that question?
Yes, thank you very much. Appreciate that.
Yep. Any other questions?
Hey, Trevor, I got a quick question. This is Brian.
Yep.
Hey, some scanners will come out and they say that they're, they can scan 1 million to 2 million points per second. Is there any overload of data that would cause Verity to run a little bit slower?
Yes.
Okay.
So for example, there are some scanners out there that claim they're doing an insane number of points per second. That can actually bog Verity down a little bit. And again, that's actually another reason I highly recommend the GTL, is that the GTL produces nice kind of light point clouds. And those light point clouds, again, ensure Verity can basically run at an optimum point cloud density. Did that answer that question?
Yep. Thank you very much.
Any other questions?
Trevor, I had somebody ask me the color coding for, like you're showing here, how we have the yellow, the red, the pink look to it. Can we change those in the tolerances for those?
So the color codes are hard coded. For example, yellow will always be out of tolerance. That is a hard coded. That's hard coded. As far as the tolerance values, say for example, if we want to change a bunch, all we have to do is basically come over to our item table, like right here. We can do a shift select. We can call like, I'm just going to do like a 5-inch tolerance. And now all the ones we've changed will be 5 inches. You can probably see if we did this, now we have a couple more that are basically green and in tolerance because we've boosted it up. So at any point you want, you can go back through and change the item table to adjust tolerances, but the color codes themselves, those are hard coded inside of Verity. Did that answer that question?
Yes. And what do the colors actually mean? Since you do have so many different colors.
Yep. So green is in tolerance. Green is good. Yellow is going to be out of tolerance, but red is not found. So that is an element that does not have any point cloud data associated with it. For example, if they just completely did not build an I-beam out in the field, I've seen that happen. The other kind of colors, purple is going to be occluded or in shadow. That means basically there's something like a wall blocking the kind of line of sight to the element, and it's in the shadow of something else. The other color is that kind of lightish red or pink. That's salmon. The joke is it's salmon because it's fishy, because Verity is not sure. That's basically an uncertain one. Teal, which is the last color, teal means there's not enough data, and that could be those are basically the color codes inside of Verity. Did that answer that question, Andy?
Yes, sir.
Yep. Any other questions?
All right. If you guys have any questions from today, please feel free to reach out to myself or any of the TopCon representatives. We'd be more than glad to try to find your best answers for you. And with that being said, that would, I guess, conclude today's little tips and tricks of the Verity software. Thank you so much.
All right. Take care, everyone. Bye.